All right, what we're doing today is lesson 1-2. It's kind of three different things: coterminal angles, reference angles, and special angles. And so we're going to start with coterminal angles. Coterminal angles are two angles that share a terminal and initial side. So if you have a 30-degree angle, for example, if I went all the way around and ended at that same spot, notice that I would be at that same ending position. And so I would have this. Well, if you think about how I get that number, is I'm going a full circle, which is 360 degrees, and then I add the 30, and that gives me the 390 if I went in a counterclockwise direction. Well, if I, instead of going in a counterclockwise way, I could go in a clockwise manner, and you can see that that's negative 330. How would I get that? Well, I'd take the original 30 and subtract 360. So here's the good news. I did it with degrees because that's something you're familiar with. The nice thing with coterminal angles is here is what I want you to think. When you see coterminal, I want you to think either add or subtract 360 if you are in degrees. If you're in radians, well, what would that be if you're in radians? You would add or subtract 2 pi. So let's do some examples. It says give two angles, one in a clockwise direction and the other in a counterclockwise direction, that are coterminal to. So it doesn't matter which one you do first. I'm going to do the positive one first. So I'm going to go counterclockwise. But if I take 140 and add the 360, then that gives me 500 degrees. And that would be a coterminal angle. Again, 140 and 500 start and stop at the same spot. If I wanted to find a clockwise, that would be going in the negative direction. I would take the 140 and subtract 360, and that would give me negative 220. So your two coterminal angles that they asked for would be these two. Now you try to do number 2. And I'm just giving you a little visual here. Of course, negative 60 would be about there. So think about going this way and then going all the way around this way. So I would do the same thing. Negative 60 plus 360. It's an easy one. That would give you 300. And then negative 60 minus 360 would give you negative 420. And here are your answers. Okay, I want to give you an idea of what they do on testing situations. Is that sometimes what they do is they give you a range. Instead of just saying, give me any coterminal angle, because really there's an infinite number of them, they give you a specific range. For example, give me a coterminal, I'm looking at number 2, give me a coterminal angle to negative 60 that's between 360 and 720. So that's the question. It wasn't worded the exact same way as the notes. It says, give me a coterminal angle to negative 60 that's between 360 and 720. Well, your brain should think, well, let me add 360, because subtracting, of course, would make my answer more negative. That's not what they want. If I add 360, I'm at 300. Is that the correct answer? No, it's a coterminal angle, but it's not the one they want. So if they ask you for one between 360 and 720, you'd actually have to add 360 again and get 660, and that would be the specific answer that they want. There's only one answer there in that range. So know that you can add 360 and subtract 360 more than once to get more and more coterminal angles. All right, let's try another one. Pi over 4. Now the radians, remember, we add or subtract 2 pi. It's just in radians, it looks a little different in every problem because of common denominators. If I'm going to add 2 pi to pi over 4, that means my denominator needs to be 4. Of course, quickly to get that, I just double it and put it on top. So I'm going to add and subtract 8 pi over 4. So I get 9 pi over 4 is one answer. And then when I subtract, I would get negative 7 pi over 4. And those are my two. With negative 2 pi over 3, what is 2 pi going to look like? Because I always add or subtract 2 pi. With a denominator of 3, my numerator will be 6 pi. So I get 4 pi over 3. And I probably wouldn't even have to show you this, but just in case, I would get negative 8 pi over 3. And those are my two. So that's coterminal. And that's an important thing because you'll be using that idea over and over throughout this unit. So coterminal angles, their starting position and their ending, their terminal side, their initial side and terminal side are the same. All right, next thought. The next thought are reference angles. A reference angle is the smallest, two very important words here, positive acute angle determined by the x-axis and the terminal side of theta. So in other words, if it says find the reference angle, people, if it's positive and acute, that means your answer better be between 0 and 90. If you're not giving me an answer between 0 and 90, your answer is not going to be correct. Okay, if you're in degrees, and of course 0 to pi over 2 would be radians. So all reference angles, they are positive and acute. All right, so let's do this. And I'm actually going to do this in a kind of weird way. Not a weird way, but there are formulas. But honestly, the formulas, I suggest drawing. And if you draw it, you can reason it out more than the formula. Because I don't want you just to memorize formulas and don't understand why you're getting that. So I'm going to do it without the formulas, and then we'll go back and actually do the formulas. We're going to start again with degrees, because that's something you're probably a little more familiar with. It says draw each angle in standard position and find the reference angle and label. Okay, 140 degrees. Where would that be? Well, 140, that's going to be, not that you have to be super accurate, but it's somewhere over here, like that. And this is your theta. Okay, so that's my standard position of my angle. Now let's think about where the reference angle is. The reference angle, notice what it says. You go from the terminal side of theta, terminal side of your angle, to the x-axis. So right here is my reference angle. Now, if I ask you what that angle was, I'm guessing you didn't use a formula. You just looked at it and said, well, if all this is 140, I know that this is 180, so what is alpha? Well, your reference angle, of course, is going to be 40 degrees. You just got that by looking, and you'd be exactly correct. Perfect. Let's do number 6. Let's draw. So 310. What quadrant is 310 in? Well, I know here is 270, so 310 is somewhere in there. And my theta is all the way around. That's 310 degrees. Now let's draw where alpha is. You always put your pen on the terminal side and then go to the x-axis. Sorry, my pen does a straight line. It's that little thing there. It doesn't matter if you're going in a clockwise or counterclockwise way when you're naming the reference angle. So that's why I don't put an arrow on that. You're just doing the amount. So what is that amount of that angle? Well, you know, if this is 310 and this is 360, so how much more do I need to make that full circle? Your alpha is going to be 50 degrees. Perfect. Now let's do radians. Radians is a little bit harder. Maybe figuring out where they are might be, but that's good practice to do that as well. So let's check it out. 10 pi over 7. And I know you could say, well, I could change it to degrees, but I hope that you can kind of reason that out without doing that. Remember, if I put common denominators of 7, this would be 0. This would be 7 pi over 7. Not 7 pi over 7 pi, 7 pi over 7. And if I went all the way around, that would be 14 pi over 7. Okay, what's half of 7? That would be 3.5. So that would be 3.5 over 7. And if I added that, that would be 10.5 over 7. So with that being said, where is 10 pi over 7? It is down here in quadrant 3. This is my angle all the way around. That's my theta. Now where's my reference angle? My reference angle, remember I put my pen on the terminal side and head to the x-axis. So this is my theta. Now think about what that's going to be. Here is 10 pi over 7. I've got to get back to 7 pi over 7. So 7 pi over 7, which is of course pi, to 10 pi over 7, what's left? 3 pi over 7. So my reference angle is 3 pi over 7. All right, last one. Pi over 5. Well, that's in quadrant 1. Here, this is your theta. That's theta. And then your reference angle, put your pin on the terminal and go to the x-axis. So gosh, that's your alpha as well, the same exact angle. Well, that's an easy one. It'd be the exact same thing, would it not? And there are your reference angles. So that's why I think drawing is the easiest thing. Now let's we'll sum it up down here and hopefully this will make sense. But again, I hope you don't just memorize formulas. I hope that you understand and it will make a lot more sense. In quadrant 1, this angle, that was like example 8. Here's your theta, and that's also alpha. So your alpha is your theta. They're the exact same in quadrant 1. So that's easy. In quadrant 2, change color so you're not confused. This is your theta. Your alpha would be here. Now let's think of what the formula would be. How did we get alpha? Let's go back to example 5 here. How did we get 40? Now I know you just looked at it and saw, but what you really did is you said, well, I'd have to take 180 and subtract the 140. And that is exactly your formula. And if you were doing radians, it would look like that. What did you do in quadrant 3? Well, in quadrant 3, your theta is here and your alpha is here. So if you think about that, what we did all the way around was 10 pi over 7. You kind of subtracted out this part, which was pi, or 7 pi over 7, and that gave you your answer. So alpha is your theta minus 180 if you're in degrees, and theta minus pi if you're in radians. And then finally, quadrant 4, we went all the way around to 310. How did we get the 50? We said all the way around was 360. We then subtracted the 310, and that gave us our answer. So again, here's our theta. Our alpha is here. So I have 360 minus theta, or 2 pi minus theta. So I want to be clear, these formulas are true if your theta is between 0 and 2 pi. So I want to be very clear, theta is between 0 and 2 pi, or 0 and 360. So I want to just make sure you understand I didn't give any negative angles in the example. So like if I gave you a theta of negative I'll do a degrees. Negative 40, well, that's here. This is negative 40. That's my theta. Well, what's my alpha? Well, my alpha would just be 40. So I don't want you to think that, oh, I'm in quadrant 4, so I'm going to do 360 minus a minus 40 and give me some large number. No, that's why I like drawing better than the formulas. But as we get into trig solving in the next unit, these formulas are going to play more of a part. So I wanted you to have them in your notes. Honestly, with reference angles, I would just draw for now. All right, last thing. Last thing are the special angles. Now, these special angles are going to become your BFFs, and you are going to know so much about these special angles as we move forward. And so the circle is divided into certain angles. Now, the ones that are listed there, I'm going to kind of do these with ones you know. It says radians and degrees. Let me start with the degrees, because again, that's what you're familiar with. You know, if I ask you if I started here and didn't go anywhere, you'd say that's 0 degrees. And if I went all the way around the circle, you would say that I'm going to put it down here, signifying like all the way around, would be 360. You know this would be a 90-degree angle. You know that this is 180. You know that this is 270. I don't think that's anything earth-shattering there. You know those. Well, what about these middle angles? Well, those totally split the quadrants. And remember, those angles right there are called the quadrantal angles, just FYI. Those on the axis are called quadrantal angles. Okay, the one in the middle of the quadrants that split them in half, well, it splits them in half. So what's halfway in between 0 and 90? Of course, that is 45 degrees. And if I ask you what this one was, what would be 90 plus 45? So that's 135. And this one, and again, I'm going all the way around. I'm not just drawing it every time, would be 225. And this one, that would be 270 plus 45, and that is 315. So those are your special angles of those in degrees. Now in radians, we know that I have 0 and 2 pi, because we know a full circle is 2 pi. Well, then half a circle would be pi, and half of that would be pi over 2. So this is pi over 2 up top. And then if I add these together, 270 is, of course, pi plus another pi over 2. That is 3 pi over 2. Perfect. And then all the way around is 2 pi. In the same way that I did it in degrees, what's half of pi over 2? Well, that would be pi over 4. So these are going to be your pi over 4s. And in a sense, I can count, because if you look at all the lines that are drawn, 1 pi over 4, 2 pi over 4, which of course reduces to pi over 2. This is 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4, and 8 pi over 4, which is 2 pi. So if you notice that the 45s, those pi over 4s, they go by odd numbers within the quadrants, 1, 3, 5, and 7. And that's kind of how I memorize those guys. All right, let's do the last ones. If you look at the circle, it's divided a little differently. If I count, I'm just going to do this one by counting, and then we'll kind of sum it up at the end. If you count the number of little sections, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, if you have 360 degrees that you have to divide amongst 12 sections, that's, of course, 30 degrees every time. So I have 0, 30, 60, get him out of the way, 90, 120, 150, 180, 210, 240, 270, 300, and 330. And of course, I still have the 360. Now, what do we got in radians? Well, once again, these aren't changing. 0, pi over 2. We already kind of know those. 3 pi over 2. So those we already know. Let's do the same thing. If I divide 2 pi divided by 12, that gives me pi over 6. So I'm literally going to go around this circle, and I am going to count by pi over 6, and I'm going to reduce when I can. So this is 1 pi over 6. This is 2 pi over 6, or pi over 3. 3 pi over 6. 4 pi over 6. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 reduces, 9 pi over 6, 10 pi over 6 reduces, and finally 11 pi over 6. So I'm actually going to change these into different colors for you to notice something, is that notice that once I do the reducing, all of the pi over 6s are close to the x-axis. That kind of sounds silly, but it kind of helps me remember. Pi over 6 has an x in it, so those are the ones that are by the x-axis, and the pi over 3s are the ones that are by the y-axis. So those special angles, you have to know where they are. When you put them on one circle, just so you know, the pi over 4s, of course, are kind of right tucked in between. So if I overlaid those two circles, my pi over 4s would kind of fit in right there in those red spots. So those are the special angles. Learn them well, know where they are, and we'll be good. All right, see ya.